So this is going to be all about traditional multiplication of multi-digit numbers. I actually do like lattice, but the Common Core now is saying everybody needs to know the standard traditional algorithms. They have been found to be the most efficient. If you remember the lattice, setting up the lattice is a bit of a nuisance. So in general, the reason why this traditional method works is because if you're doing 41 times 23, it could be broken down into 41 times, and then I just did 3 times 20. Because if you think about traditional, I'm going to do the 3 times the 41, and I'm going to do the 20 times the 41 as two separate parts of it. So 41 times 3, and I add up to it the 41 times 20. So it's just a distributive property that allows this strategy to work. If you already know this strategy, I just have a couple of tips to help you with making sure you're doing it well. So you can use grid paper to keep your work organized. You don't have to, but some kids, when they're filling in, their work gets so mishmashed and off to the side and stuff. When they're adding up the numbers at the end, they're not keeping them lined up. And they're accidentally lining up something that's in the tens place with stuff that's in the hundreds place, or something like that. Another idea, and this one I learned from a student, and I saw that a lot of you on the pretest already do this, which I'm like, yes, you guys are awesome. You may want to cross out numbers you added because of regrouping or because of carrying to avoid adding them again later. I saw a lot of kids accidentally adding that thing that they did a carry for this, 8 times such and such when they were on the 2 times such and such in the second example first. We'll see it when we go through the process. And they would accidentally add it again when they weren't supposed to. So someone had the tip of crossing it out. I'm like, I like that. So now I do that as well. So I just want to make sure I'm not going to be accidentally adding it when I'm already done with it. So let's go through the first example, 41 times 23. Try to keep the numbers simple so we're looking more at the process of it. So first, we're going to multiply the 3 times the 41, but we're only going to do one digit of the 41 at a time. So first, and I know you're in 6th grade, and it's difficult now, but what's 3 times 1? What's 3 times 1? 3. So we've taken care of this one's 1's place times that one's 1's place. So it's that whole idea of the partial products, except we make nice and succinct. Then we're going to do this 3 times 40 essentially, but because we're going to put it over to the left of that 3, it's going to fill it in the right place. So then all I really have to think about is what's 3 times 4, sir? 12. And when I put it over in this place, it really makes it 120. So unlike the partial products, I don't have to make another line for the 123 and 120. I saw some people on that pretest doing partial products, and they just either missed some of the parts of it, or they redid it but in a different order, and they had more than they needed. So that's one of the reasons we're not doing partial products. And then the other thing about the partial products, sometimes you get such a line of stuff, it's just horrendous. Let's try to keep track of that. Now we're going to go to this 20 times 41. In order to make it so that all the numbers fall into the right place value, we start by putting a 0 here. I did see some people leave just a space there, and your textbook even does that. I really discourage leaving a space there. Because again, if you're not using grid paper, things might not get lined up. So either put a 0, I've seen some people put an X, and that's kind of okay if you go bowling and X means 10. So at least that makes some sense. But a 0 is the most significant, because it really means that this number that follows is going to be a certain amount of 100. We'll see in a second. All right. So again, 6th grade, challenging problems, 2 times 1. 2 times 1, sir? 2. You guys are awesome. 2 times 4. Man. 8. So that 0 there is because 20 times 41 equals 820. So that's why that 0 is the best option, because it is significant. It lets us read what that is and where it comes from. And then we're going to just go ahead ahead and add them up. That's the whole idea of the distributive property, is I can pull things apart and multiply into the pieces that I have that would add together. All right, I need 3 plus 0. Sir, on the way back. 3 plus 0. I'm just adding here. 3. I thought you said 30. I might have heard it wrong. I could turn those hands back on too. And then I need 2 plus 2. Wait, no, you.
Oh, 4.
4. I'm using my sticks, but I don't want to call names because I use these videos for always and forever, or at least for now. And then 1 plus 8 is 9. So therefore, 41 times 23 is 943. If you were a lattice person before, people that don't know lattice wouldn't know what the heck it was until you rewrote it. If you're not using lattice, then you have your answer right here. Ta-da! You don't have to rewrite it someplace else, unless there's like put your answer over on the spot. Which you just got to be careful if someone on their pre-test got the right answer and then wrote it wrong in the. You didn't even need to rewrite it; they rewrote it and then wrote it wrong. So be careful when you rewrite your answer in a answer spot or what have you. All right, let's do the next one. We need to know what 8 times 5 is. 40. So in this case, since we're only dealing with one digit at a time, one place value at a time rather, we put the 0 here and we carry the 4 so that we're dealing with it when we're in the tens place. And again, nobody should be jumping ahead, everybody's doing each line as we go through it. 8 times 3 is what? 24. But now that we're in the tens place, we need to add that 4 to get what? 28. But it's really 280 when we're dealing with that at this point. And we're going to put that 2 over there. And this is where we do that, cross out that 4, so we don't accidentally use it later. And then the last step, when I'm going this slow, sometimes I can, and I think I'm on the last step. 8 times the 1. Are you sure?
10.
8 times 1 is not 10. 8. And then the 8 plus the 2. 10. But now that I'm here at the final part, I don't have to carry it up and just write it down. I don't have anything more going on that is getting in the way of. Can't believe you think 8 times 1 is 10. He was jumping ahead. I see how it is. Alright, yeah, we're going to be dealing with 20 times 100. You sneeze. We're going to be dealing with 20 times 135. So what do I need to put here? 0. I'm going to be famous now. We're going to be like, I heard your name on the interview. Alright, so now we're ready to deal with 2 times 5. 2 times 5. Hold on, hello, 4. Everyone's here today, right? We're in red class. Didn't I do attendance? All you guys were working? Oh! He's not in red class anymore. Remember yesterday? Oh, yeah. He switched because they had 3 kids in the yellow.
Yeah.
We'll still see him. Don't worry. Don't cry. Don't cry. Okay, so 2 times 5. 10. And the reason I use that specific example is because sometimes that 0 throws people off because they're like, wait, I already put a 0. No, now we're in the tens place putting the 0 because 20 times 5 is really 100. And we need to carry over to the next place value, the 1 of the 10. You can't put 2 digits in one place value. So now we're going to do 2 times 3, sir.
5.
2 times 3.
Oh, 6.
And then plus the 1 more. Plus the 1 more. 7. And there's nothing I need to carry. Good thing I crossed that out so I don't accidentally use it. Yeah. And now I'm going to be on my last step. What is 2 times 1? 2. And there's nothing I need to add. There was nothing carried from the last step. So now I'm going to add up all of my digits. calling them mix. What's 8 plus 0? In the back.
8.
What is 0 plus 7? Sir.
7.
And what's 1 plus 3? 1 plus 2. My brain went ahead. Sorry about that. 1 plus 2, ma'am? 3. Okay, when you have a 4-digit number, commas are optional. But, might as well put it in because that way hopefully you won't forget it when it's a greater than 4-digit number. So commas are optional when it's 4 digits. You could have it or you could leave it alone. But if it's more than 4 digits, you have to have a comma between. Alright, let's make this last one go a little bit faster. What is 9 times 3 on the way back? 27. I'm going to put down the 7. I'm going to carry the 2. What is 3 times 2 plus that 2? Man. 3 times 2 plus that 2. It's going to be the 8. I'm going to cross out that 2 so I don't accidentally add it later. Now I'm on the 3 times 9. 3 times 9. 27. 2, and I don't have anything else going on, so I can put that 27 down completely. Well, the next one, I'm now in the tens place, so what do I need? A 0, just a single 0 to bump me into the tens place. And then, what is 1 times 929? What is 1 times 929?
929.
I don't have to go 1 digit at a time if I see that it's 1 times something. You could, but you don't have to. Just like if you see that it's 0 times something, you don't even have to write that line. Because that means, oh, it's not going to give me any value, I'm just going to get to my next place value and deal with that. Alright, now we're on the hundreds place. So what do we need to deal with the hundreds place, sir? I need 2 zeros this time. So that's the thing, is every time I get to another place, I have to bump myself over to the hundreds place or to the thousand place if I had 4 digits going. Alright, now what's 6 times 9, 6 times 9, 6 times 9, 6 times 9? Oh, he's like, I'm on the spot. She's talking so fast now. She sounds like an auctioneer. I don't like that. 54, so I put the 4 down, carry the 5. Now I got 6 times 2 plus that 5. 6 times 2 plus that 5. 17. So I'm going to put the 7 down. I'm going to carry the 1. And I just, out of a habit, I crossed off that 5 even though I don't have any more digits I'm going to be dealing with. Now I'm going to want 6 times 9 plus the 1. 6 times 9 plus the 1 in the way back over here. Can you stand? 6 times 9 plus 1.
56.
No. So close.
55.
55. So close. You couldn't be much closer.
Oh.
Alright, now we're going to add these up. Just double checking that we didn't make a mistake along the way. Sometimes when I'm trying to go slower, I do something, but I think we got it all. 7 plus 0 plus 0, sir.
7.
I'll take it from you. And then 8 plus 9 plus 0, sir, next to you. Next to him.
17.
17. So we have to put down 7 and carry this 1. Now we have 1 plus 7 plus 2 plus 4. I group them, I look for 10s. So the 1 or 7 and the 2 make a 10, and then I still got 4 more. Anyway, you can do it however you want to get 1 plus 7 plus 2 plus 4 is what? Yeah, 14. I messed myself up because I only went 1. Carry that 1. I'm not even putting them in the right place because the smart board is slightly off. Sorry. Oh, trying to move. Alright, and then we have the 1 plus 2 plus 9 plus 7. Again, I'm up to 10. What do we get when we add 1 plus 2 plus 9 plus 7? Right, I just got 1 from you. So now I want 1 from you.
Yeah. 19.
No, 19. That's a song. Anyway, 1 plus 5. 1 plus 5 is what? What's 1 plus 5, ma'am? 6. And lastly, what's 5 plus nothing else at all? Sir? 5. So what do I need to do to finish off this answer? Between where and what?
Well, including 9 and 4.
Put a comma comma between the 9 and the 4. If it was like a skill drill or something, you'd circle it and say, yep, that's my final answer, no kidding.